we're asked to come up with a rational function for this graph. The first thing I see is that there's a vertical asymptote at -2. That must mean we have x plus 2 in the denominator. That's the only way we could have that divide by 0 problem. And that's when vertical asymptotes happens, when you have a divide by 0 problem. Now, x plus 2 actually would look something like this for a vertical asymptote. That's what this vertical asymptote looks like. You've got a negative side and a positive side. But this graph, the vertical asymptote, they're both going towards what we'd say is positive infinity. They're both rising. They're rising instead of falling. Like if you were to graph 1 over x, sketch that graph, you'd see it's like this on one side and like this on the other side. Okay, but if you graph 1 over x squared, you've taken all these negative numbers and you made them positive. So it would look like that. So that's what we need to do for this graph. We need to square that denominator. That way we can turn this from a negative into a positive, just like it is on this graph over here. We've got to square the denominator. What else? It crosses at x equals -3. So the x-intercepts should always be taken care of in the numerator. We need that to cross at x plus 3. Now if you were to plug in -3 plus 3 makes 0. And then 0 divided by whatever this is going to be 0. So -3 comma 0 would be a point. So x-intercepts, those go in the numerator. Vertical asymptotes, those go in the denominator. And let's see, the last thing would be just to check, because sometimes you can scale these by multiplying what Newton would say is times some constant a. We just need to figure out what that number is. Maybe it's 1, maybe we don't need to modify anything. But let's see, I don't see any points. Like I'm looking for -1 comma 2 or something like that. Oh, okay, I didn't see this up here. Oh, they even just spell it out. Vertical asymptote at -3, we already found that. Wait, no, intercept at -3, we found that. Vertical asymptote at -2, we found that. And then this, the y-intercept of 3/2. So if it's a y-intercept of 3/2, that means at 0 on the x, we have 3/2 for a dot for y. So for this function, when we can figure out what a is based on that information. Okay, so a should be the last thing you solve for. You plug 3/2 in for f of x. And then you're going to plug in 0 in for x. And then if we simplify the right side, that's 3 in the numerator and 4 in the denominator, so we can multiply both sides by 4/3. That's going to make 2, because the 3's cross cancel when you multiply both sides by 4/3. So the 3's are cross canceling. And then 4 divided by 2 makes 2. So we found out a equals, a equals 2. Okay. And so that's the last piece. This needs to be a 2 out front. So maybe pause the video and try to do this one along with me. But I'm going to do the same thing. I'm going to start with my vertical asymptotes. Vertical asymptote at x equals 4. So that means I need x minus 4 in the denominator. That way, what was I going to say? That way we have a divide by 0 problem at x equals 4. And that's where vertical asymptotes occur. And then we need to square this for the same reason as in the last video, to make both sides be positive to the left and the right. You might be wondering, well, this dips into the negatives and then goes positive, but that's just because of adjusting the numerator, which we're about to do. So it crosses at x equals 3. That's the x-intercept. That means we need to have x minus 3 in the numerator. That way, if we were to plug in 3, we get the y value would be 0. The last thing we need, this function's almost done. We just need to find out what a is, multiplying this by some number a. And so to figure it out, they told us y equals -3/4 when x is 0. That's what a y-intercept is. X is 0, and then y would be -3/4. Oops, so that's -3. Plugging in 0 everywhere because they told us that's the y-intercept. So it's -3/4 equals -3 over, this is -4 that's being squared, so that's 16. So to finish getting a by itself, I'm going to multiply both sides by the reciprocal. So when I cross simplify, these are gone. 16 divided by 4 makes 4, so it looks like a should be 4. So my final answer for this function would be, you could put the multiplying by 4 on either side, but it's 4 times x minus 3 over x minus 4 squared.